lesson is about adding and subtracting rational expressions. This is page 73, it looks like, in our Algebra 2 Honors Notebook, or whatever page I have indicated for the class that I'm doing this for. Currently, this is for Reimagine Time Day 40 and 41, and these are on Student Journal page 207, 208, and 209. The first thing I want to remind you is that you have to have a common denominator in order to add or subtract fractions, or another word for fractions are rational expressions. And then once you've found that common denominator, then you need to reduce if possible. Now remember to reduce when you're working with rational expressions. So remember, you can only reduce if you have monomials with monomials, binomials with binomials, trinomials with trinomials. You can't take part of a monomial and reduce it with part of a binomial. You also cannot take part of a binomial and another part of a binomial and reduce it. When you reduce those binomials, they have to be entirely the same to reduce. So what I mean by that is if you have x plus 1 over x minus 2, you cannot do that. You can't do that. But if you have x plus 1 over x plus 1, you can do that and say the answer is just 1. So that does reduce away and the answer would be just 1. Okay, so let's get to the lesson for today. Find the sum or difference. The first thing I'm going to do is subtract these two rational expressions. Do they have a common denominator? X minus 1, that entire denominator, and this entire denominator are the same. You don't look at these as x and negative 1 and negative 1. This is x minus 1, this is x minus 1. Yes, I have a common denominator, so I'll keep that denominator. Then I will subtract my numerators. 1 minus 5 is negative 4. Can I reduce anything? No, I cannot. I have a monomial in the numerator and a binomial in the denominator. This is my answer. When I look at number 2, do I have a common denominator? 3x minus 5, 3x minus 5. Yes, that is my common denominator. I'm going to erase this. So 3x minus 5 is in my numerator, and then I am going to add my like terms in my numerator. So 4x plus 1x is 5x. Now can I reduce? I have a monomial and a binomial. No, I cannot reduce. Some students think they can reduce this away. No, you may not. You have a monomial 5 and a 5, a negative 5 actually, in your binomial. You cannot reduce those together. Okay, moving on to number 3. Do I have a common denominator? Yes, x plus 4 is my common denominator. Do I have like terms in my numerator? I cannot add those together, so I'm going to have to put 6x plus 24. And then when I look at that, I recognize that my numerator has a common factor. And if I factor out that common factor, then I believe I can reduce. So let's try that. I'm going to go up here to the top of my paper. I'm going to take out the common factor here of 6. So that'd be 6 times the quantity, x plus 4. I'm going to bring up my denominator, x plus 4. And I don't think you can see that very well, but I'll make that happen. Okay, now, I have a monomial, a binomial, and a binomial. Can I reduce those two binomials? Are they the same? One in the numerator and one in the denominator? Yes, so I can get rid of this. The answer is just, I'll write it up top. The answer to number 3 is just 6. That's the answer to number 3. Okay, moving on to number 4. Do I have a common denominator? Yes. x minus 7 is my common denominator. I don't have like terms in the numerator, so I'll bring over 2x squared minus 14x. I do notice that my numerator can factor. There is a greatest common factor of 2x. So I'm going to factor out that 2x from the numerator. That would leave me with x minus 7. Now I have a monomial, a binomial, and a binomial. Are my two binomials, one in the numerator and one in the denominator, the same? Yes. So then I would reduce these away. My final answer is 2x. Okay, moving on to Student Journal 209, talking about the least common multiple. When you see monomials, the only thing that you're going to think about would have to do with the variables. Of course, we know how to find the least common multiple of the coefficients or the constants. In this case, it might be a constant, but normally they're probably going to be coefficients. Anyway, you're going to choose the largest exponent for your variables when you're finding the least common multiple. And that's sort of the reverse of what we said with the greatest common factor, because greatest common factor, you use the smallest exponent, but when you're finding the least common multiple for monomials, you choose the largest exponent. Now, for binomials and trinomials, you want to make sure these are factored first, and then we'll choose what they have in common after they're factored. Okay, so for number 5, 6, and 7, my job is to find the least common multiple. So this is a monomial. I can't do anything with it. I'm just going to bring it down and write it down. This is a binomial, and I can factor this binomial. There's a greatest common factor of 3 and of x. So I'm going to factor out 3x, and that will leave me with x, subtract 7. So I have monomial, monomial, binomial. When I'm thinking about the least common multiple, there's not another x minus 7, but it has to be included in my least common multiple. So x minus 7 is part of my least common multiple. Now let's look at our two monomials. I have 9 and 3. When you're finding the least common multiple, you want the largest number that both of these can divide evenly into. Students want to say 3 is the least common multiple, but 9 does not divide evenly into 3. So the least common multiple is going to be 9, because 9 goes into 9 and 3 goes into 9, so 9. And then here's a variable, I have x cubed and x, and it says choose the largest exponent. So 9x cubed times x minus 7. That's the least common multiple for question 5. Working on question 6, I made a mistake already, so I had to erase. I brought down x plus 5, and I found factors of 10 that will give me a sum of 11, and that's 1 times 10. So I'll bring down x plus 1, x plus 10. I'm doing the bottoms up method. This won't reduce, so this will be 2x plus 1. This will reduce, it'll be x plus 5. Quickly, I can check that. 2x squared, yes. Plus 10x plus 1x is 11x plus 5. So yes, now I'm factored completely. Now, let's look at this first term before the comma and then the two terms after the comma. Do they have anything in common? Yes, they both have x plus 5. So x plus 5 is part of my least common multiple. And then 2x plus 1 isn't anywhere else, but I have to include it in my least common multiple. So the least common multiple for x plus 5 and 2x squared plus 11x plus 5 is x plus 5 times 2x plus 1. Okay, now I have a trinomial and a trinomial. Can I find factors of 6 that will give me a sum of 5? Yes, 2 times 3. Can I find factors of negative 18, a times c, that will give me a sum of negative 3? Yes, negative 6 times positive 3. Then I'm going to put x plus 2, x plus 3 for this first trinomial, x minus 6, x plus 3 for that second trinomial. Then I want to look at these two binomials, this product and this product. Do these two products share something? Do they have the same thing? Yes, they both have x plus 3, so that's part of my least common multiple. Then does this one have an x plus 2? No. So it has to be included in my least common multiple. Then does this one have an x minus 6? No, it has to be included as well. So the least common multiple for this trinomial and this trinomial is the product of those three binomials. And that would be finding your common denominator. That's why we did this. The least common denominator when you're working on adding and subtracting rational expressions, the least common denominator is the least common multiple. So let's look at number 8. These are different, number 8 and number 9, and so on to number 11. These are different because we do not have a common denominator. So the common denominator, when I look at this, I have 2x and 5x. I'm going to put 2x and 5x here. They're both monomials, so the least common multiple, the largest number that both of these will divide into, or you can think about multiples, 2, 4, 6, 8, 10, 12, 14, 16. And for this one, 5, 10, 15, 20, 25, 30. Of those numbers that I just listed verbally, the least that they have in common is 10. And then they both do have x. So the least common multiple here is 10x. The common denominator is 10x. Then here's what I ask students to do. 2x compared to 5x. Oops, and you can't see that. Apologize for that. How do I turn 2x into 5x? Excuse me, how do I turn 2x into 10x? I multiply by 5. Oh, not down here. I'll just say that again and I'll delete it out from the video. How do I turn or transform 2x into 10x? Multiply by 5. So if you're going to create an equivalent fraction, you're going to multiply this by 5 as well. So 3 times 5 is 15. 2x times 5 is 10x. Now let's look at the next fraction. How do I transform 5x into 10x? Well, I multiply 5x by 2. So to create an equivalent fraction, I need to multiply the numerator by 2 as well. 11 times 2 is 22. So now, do I have a common factor? Yes, I do. 10x is that common factor. What's 15 plus 22? And I believe that's 37. Now, can I reduce, because I do have a monomial over a monomial. Can you reduce those two monomials? No, you cannot. So this is the answer to number 8.